Good day everyone, welcome back to the channel. In this video, we are going to talk about customizing the prompt. In this section, we'll delve into what might appear insignificant at first glance, the shell prompt. Exploring this will uncover the intricate mechanism within both the shell and the terminal emulator program. Within the realm of Linux, the shell prompt offers extensive customization. Despite often overlooking its potential, mastering its control reveals its tremendous utility.
Unlock the world of Daisy Ninja puzzle books, where excitement meets brainpower. Dive into the mind-bending labyrinths of Maze Mastermind. Conquer the Sudoku challenges in Sudoku Ultimate. Uncover hidden words in Word Search Wizard. And decode mysteries in Word Spy Adventures. Whether you're soaring above the clouds or speeding down the tracks, turn your downtime into brain-boosting fun. Perfect for all ages, these books guarantee hours of entertainment. Daisy Ninja Puzzle Books, your passport to endless excitement on the go. New release each month.
Anatomy of a prompt. The standard prompt appears as follows, which it does, like over here. It showcases our username, host name, and the current directory, but how does it take this shape? Surprisingly, it's quite straightforward. The prompt is set by an environment variable called ps1, short for prompt string 1. To view what ps1 contains, you can use the echo command. So let's check this out. We'll say echo ps1 and make sure to mention the $sign because this is a variable, right? So in our case, the ps1 variable includes the following text. If your output doesn't perfectly match the example provided, there is no need for concern. Each Linux distribution crafts its prompt string with its unique touch, resulting in some rather distinctive variations. Okay, the outcomes reveal that ps1 holds some familiar characters present in our prompt, like brackets, the @ sign, and the $sign, while the remainder remains somewhat enigmatic. For those observant, these resemble \escaped special characters discussed in Chapter 7. Below is a partial roster of such characters that the shell treats uniquely within the prompt string. Okay, so /A means ASCII bell. This makes the computer beep when it is encountered. /D, current date in day, month, date format. For example, Monday, May the 26th. /H, host name of the local machine minus the trailing domain name. Capital H means full host name. /J is the number of jobs running in the current shell session. /L means the name of the current terminal device. /N is a new line character. /R is a carriage return. /S is the name of the shell program. /T, current time in 24 hours, which is hours, minutes, seconds format. /T, current time in 12-hour format. /at is the current time in 12-hour, that is AM or PM format. /A, current time in 24 hours. /U, username of the current user. /V, version number of the shell. /V, version and release number of the shell. /W, name of the current working directory. /W, last part of the current working directory name. !, history number of the current command. #, number of commands entered during this shell session. $sign, this displays a dollar character unless you have super user privileges. In that case, it displays a hash tag instead. Okay, the square bracket, the left square bracket signals the start of a series of one or more non-printing characters. This is used to embed non-printing control characters which manipulate the terminal emulator in some way, such as moving the cursor or changing the text colors. The right square bracket signals the end of a non-printing character sequence. Okay, trying some alternative prompt designs. Using the special character listed, we can alter the prompt's appearance. Initially, let's safeguard the current string for future restoration by copying it into a new self-made shell variable. So to do that, we'll say ps1 underscore old equals the value from the ps1 variable. Okay, when you press the enter key, the values from the old ps1 variable is now saved in the ps1 underscore old variable. Okay, the new variable ps1 underscore old now holds the value of ps1. To confirm the copy, we can utilize the echo command. So to make sure it has happened, we'll say echo $ps1 underscore old, and this should print the same text as the $ps1 did. Okay, to revert to the original prompt at any point, simply reverse the process. So to go back, let's quickly do that. We'll say ps1 equals $sign ps1 underscore old and the closing quotes. Once you do that, it is now back to its original value. Well, we haven't made any changes to the original ps1, so nothing has actually changed. Okay, once ready, let's experiment. For instance, if we set an empty prompt string like this, we'll say ps1 equals and then press the enter key. An empty string yields no prompt display, leaving just blank screen. To rectify this, let's create a minimal prompt. Now, any command, let's say we'll type ls over here, will work, but there is no prompt. Okay, let's clear the terminal. Now, let's fix the problem that we have created. We'll say ps1 equals, then the backward slash, then the $sign, then the closing quotes. Once you press the enter key, the $sign will appear on the new prompt as it does. Okay, this revised prompt includes a trailing space within the quotes, ensuring that the cursor placement after the $sign when displayed. Okay, so the one thing that we missed is we can add a space. Now there will be a space between the $sign and the actual command that you're entering. All right, now let's introduce a bell sound into our prompt. So to do so, we'll say ps1 equals backward slash the square bracket backward slash a, then another backward slash, then the closing bracket, then another backward slash, then the $sign, then the space, and then the closing quotes. The mistake that we made, it was supposed to be ps1. That's it. Okay, this addition prompts a beep with each appearance of the prompt. While potentially bothersome, it can serve as a useful notification for lengthy commands. The backward square bracket sequence are essential, as the ASCII bell slash backward slash a doesn't affect the cursor position, requiring bash to accurately determine the prompt's length. Okay, moving on, let's craft an informative prompt with the current time and host name. Let's check it out. We'll say ps1 equals quotes backward slash a space backward slash h, another backward slash, then the $sign, then the space, and the closing quotes. And now it is displaying the current time. Okay, this modified prompt includes the time of the day, aiding in tracking tasks execution timings. Lastly, let's recreate a prompt resembling the original. We'll say ps1 equals the less than symbol backward slash u at backward slash h space backward slash capital W, then the greater than symbol backward slash $sign, then the space and the closing quotes. Okay, now our prompt looks like as it does in our notes. Okay, testing other sequences from the table might lead to creating an innovative prompt design. Feel free to experiment and craft your brilliant new prompt. Okay, now let's talk about adding colors. Most terminal emulator programs respond to specific non-printing characters sequence to manage character attributes such as colors, text boldness, and even the infamous blinking effect. Initially, we'll explore color before delving into cursor position. Terminal confusion. In the early days, when terminals connected to remote computers, numerous terminal brands existed, each with unique functionalities, keyboards, and interpretation of control data. Unix and similar systems implemented two intricate subsystems, term cap and term info to navigate this diversity in terminal control. Within your terminal emulator settings, you might stumble upon an option for selecting terminal emulation type. To establish a semblance of uniformity among terminals, the American National Standards Institute, or ANSI, devised a standardized collection of character sequences for video terminal controls. Those familiar with old DOS systems might recall the ANSI.sys file, which enabled the interpretation of these colors codes. Character color manipulation involves transmitting ANSI escape codes to the terminal emulator, which are embedded within the character stream to be displayed. These control codes don't physically appear on the display, rather, they are interpreted as instructions by the terminal. As detailed in the earlier table, the backward square bracket, then the backward closing square bracket sequence serve to encapsulate non-printing characters. An ANSI escape code commences with an octal 033 derived from the escape key, followed by an additional character attribute and an instruction. For instance, the code to set text color to default attribute equals 0 with black text is this, which is /033, then the square bracket 0 semicolon 30M. Below is a table presenting the available text colors categorized into two groups based on the application of the bold character attribute, which creates the effect of light colors. Okay, so you can have a look and play around with these colors. Let's attempt to create a red prompt. We'll integrate the escape code at the start. All right, so let's get back to our home directory, clear the terminal, and we'll say ps1 equals backwards slash, then the square bracket backwards slash 033, then the square bracket 0, the semicolon 31m backwards slash, another closing square bracket less than symbol, then another backward slash u at backward slash h space backward slash w, then the greater than symbol, then another backward slash, then the $ space and the closing quotes. Once you press the enter key, your prompt is now in red. Okay, it displays in red, but notice that all subsequently typed text also appeared red. To resolve this, we'll append another escape code at the end of the prompt, instructing the terminal emulator to revert to the previous color. So if you type anything, everything will be in red. To fix that, use the following command. You'll say, after the $, you'll say backward slash, then the square bracket, backward slash 033, then another square bracket, 0m, backward slash, and then the closing square bracket. And once you press enter, and anything that you type will be in white. Okay, so this is how you can customize your prompt. Furthermore, the provided code below can set the text background color. However, note that the background colors don't support the bold attribute. All right, so these are some of the colors that you may want to play around with. Altering the initial escape code allows us to craft a prompt with a red background. So if you use this code, you can achieve a red background for the prompt. So we'll get our previous code back and we'll modify it. So we'll say 41 here and then press enter, and your prompt background is now red. Okay, so anything that you type will still remain in white. All right, now you can try the output codes and see what all you can create. Okay, do note, besides the normal 0 and bold 1 character attributes, text may also be given underscore, which is 4, blinking 5, and inverse 7 attributes as well. In the interest of good taste, many terminal emulators refuse to honor the blinking attributes, however. Okay, moving the cursor. Using escape codes allows for cursor positioning, a technique often employed to display a clock or other information in various screen locations like an upper corner. Each time the prompt appears below is a compilation of escape codes used for cursor positioning. Right, so these are some of the codes used for cursor positioning. You may go through these. Employing the provided codes will create a prompt that generates a red bar at the screen stop, showcasing a clock in yellow text. Whenever the prompt appears, the prompt code takes the form of this rather complex looking string. Okay, so to save ourselves some time, we'll just copy this code from here and we'll paste it here. And this is what the output looks like. So we'll clear the terminal, and there is a time section displayed at the top of the terminal. So anything that you type, the time will stay at the top. All right, let's take a look at each part of the string to see what it does. So let's bring back the code. So the backward slash square bracket initiates a sequence of non-printing characters. This step enables Bash to accurately determine the visible prompt size. This calculation is crucial for the precise positioning of the cursor in the command line editing features. Backward slash 033 square bracket S saves the current cursor positions. This action ensures a return to the prompt's original location after drawing the bar and clock at the screen stop. Note that certain terminal emulators might not adhere to this specific code. Backward slash 033 square bracket 0 semicolon 0H moves the cursor to the upper left corner, which is line 0, column 0. Backward slash 033 square bracket 0 semicolon 41M set the background color to red. Okay, now the backward slash 033 square bracket K erases from the current cursor position top left corner to the end of the line as the background color is set to red. This action clears the line to that color, forming our designated bar. It's important to note that clearing to the end of the line doesn't affect the cursor position, which remains at the upper left corner. Backward slash 033 square bracket 1 semicolon 33M set the text color to yellow. Backward slash T renders the present time. Despite being a printing component, it's included in the non-printing segment of the prompt. This ensures that Bash doesn't factor the clock into the actual size calculation of the displayed prompt. Backward slash 033 square bracket 0M turn off the color. This affects both the text and the background. Backward slash 033 square bracket U restores the cursor position saved earlier. Backward slash closing square bracket end the non-printing character sequence. And finally, this character sequence is the prompt string. Okay, saving the prompt. Clearly, we don't intend to type that lengthy command repeatedly. So let's save our prompt somewhere. We can ensure its permanence by appending it to our .bashrc file. Simply add these two lines to the file. Okay, so if you do wish to save this prompt, follow these lines of code. Okay, I don't wish to save them, so I'll go back to the original prompt. To achieve that, all you have to say is ps1 equals quotes, then the $sign ps1 underscore old, then closing quotes. Remember, we saved the old prompt's information in this variable. So once you press the enter key, your prompt will go back to the original way it was with your distribution. Okay, you clear the terminal and you're back to where you started. All right, so let's summarize the chapter. Surprisingly, there's a lot more to explore regarding prompts involving shell functions and scripts beyond what we have covered here. Nonetheless, this serves as a solid introduction. Not everyone will find it necessary to alter the prompt, as the default one usually suffices. Yet for those of us inclined to experiment, the shell offers countless hours of enjoyable tinkering and exploration. All right, guys, do play around if you are interested in this sort of thing, customizing your prompt, and do practice all the commands mentioned and make up your own color codes as well. In the meantime, have a good one, and I have linked the chapter notes in the description. See you later. Have a good one.